Welcome to Math on Ice, Integral Equations, June 2021 paper, Part B and C. So we will see two questions, one question from Part B and one question from Part C. Part B question, for the Volterra type linear integral equation, phi of x is equal to x plus 2 times of integral 0 to x e to the power x minus zeta, phi of zeta d zeta, the resolvent kernel r of x comma zeta comma 2 of the kernel e to the power x minus zeta is what? So let us replace the variables in our convenient form. Now here phi of x, I'll write it as y of x. So I have replaced phi by y, and later after finding the solution we will just replace again y by phi, and zeta I'm going to replace it with t. X plus 2 times of integral 0 to x e to the power x minus t into y of t dt. Here f of x will be equal to x and lambda will be 2 and kernel k of x comma t will be equal to e to the power x minus t. Now we will see the general formula. If the Volterra type second kind integral equation is given, then the resolvent kernel is given by, the question will be of this type, y of x is equal to f of x plus lambda times of integral 0 to x k of x comma t into y of t dt. If it is of this type, then the resolvent kernel r of x comma t comma lambda is equal to summation n is equal to 0 to infinity lambda power n k n plus 1 of x comma t. Now k n plus 1 of x comma t can be determined by the formula integral t to x k of x comma z into k n of z comma t into dz. And the final solution can be evaluated by y of x is equal to f of x plus lambda times of integral 0 to x resolvent kernel r of x comma t comma lambda into f of t dt, and it will have an unique solution. Here f of x, provided f of x not equal to 0 and k of x comma t is not equal to 0, and it will have unique solution. This is an unique solution. But in this problem, it is not necessary to find the solution. It is enough if we solve the resolvent kernel. So we will just evaluate what is k of n plus 1 of x comma t first, and then we will find the resolvent kernel. K of x comma t is given to be e to the power x minus t. K of x comma t is equal to e to the power x minus t. That will be equal to k1 of x comma t also. So k2 of x comma t will be is equal to t to the power integral t to x k of x comma z k1 of z comma t into dz, which is equal to integral t to x k of x comma z, which is e to the power x minus z. K1 of z comma t will be e to the power z minus t into dz, which is equal to integral t to x e to the power x minus z plus z minus t into dz. Plus z and minus z cancels each other. We will have t to x e to the power x minus t into dz. Now it is the integral with respect to z, and it is this term e to the power x minus t is independent of z. So you can take this out. So you will have it as equal to e to the power x minus t integral t to x dz. Now this integration will be e to the power x minus t into z. The lower limit is t and the upper limit is x. When you find the lower and upper, you will get it as x minus t. This is your k2 of x comma t. We need to find k3 of x comma t. K3 of x comma t will be equal to integral t to x k of x comma z into k2 of z comma t into dz. So that is equal to integral t to x k of x comma z. What is k of x comma z? It is given there e to the power x minus z. So we will have e to the power x minus z into k2 of x comma z comma t will be this one, e to the power z minus t into z minus t into dz. E to the power x minus z plus z minus t, z and minus t, z and minus z cancels each other, and we have z minus t into dz, which is equal to integral t to x, take out e to the power x minus t outside, z minus t into dz. Here t is a constant, so this will be equal to e to the power x minus t into z minus t the whole square divided by 2. Your lower limit is t and your upper limit is x. When you apply the upper limit, it will be x minus t the whole square. When you apply the lower limit, it will be t minus t the whole square, which is equal to 0. So applying the limits, we will have e to the power x minus t divided by 2 into x minus t the whole square. So this is your k3 of x comma t. Now we will find what is k4 of x comma t. k4 of x comma t is equal to integral t to x k of x comma z into k3 of z comma t into dz, which is equal to t to x k of x comma z will be e to the power x minus z, k3 of z comma t will be e to the power z minus t divided by 2 into z minus t the whole square into dz, which is equal to, take out the constants, 1 by 2 can be taken outside, and then this e to the power x minus t can be taken outside, and that is equal to t to x z minus t the whole square into dz will be left over, which is equal to e to the power x minus t divided by 2 into z minus t the whole cube divided by 3, and then the lower limit and the upper limit. When you apply the lower limit, it will be 0. So you should apply only the upper limit. X minus t the whole cube divided by 3. 3 2s are 6. So you will have e to the power x minus t into x minus t the whole cube divided by 6, which can be written as e to the power x minus t into x minus t the whole cube divided by 3 factorial. So this will be your k4 of x comma t. So generalizing the case, we will find k of x comma t, which is equal to k1 of x comma t, which is equal to e to the power x minus t, and then k2 of x comma t will be equal to e to the power x minus t into x minus t into x minus t, and k3 of x minus t will be k3 of x comma t will be equal to e to the power x minus t into x minus t the whole square by 2, and then k4 of x comma t is equal to e to the power x minus t into x minus t the whole cube divided by 3 factorial. And if you proceed further, you will find kn of x comma t is equal to e to the power x minus t into x minus t the whole power n minus 1 divided by n minus 1 factorial, and kn plus 1 of x comma t will be equal to e to the power x minus t the whole power n divided by n factorial. So what is the formula for resolvent kernel? R of x comma t comma lambda is equal to summation n is equal to 0 to infinity lambda power n kn plus 1 of x comma t. Here our lambda is equal to 2 in the problem. Lambda is equal to 2 in the problem, and then f of x is x. Okay, so lambda is equal to 2. Lambda is equal to 2 means summation n is equal to 0 to infinity 2 to the power n into kn plus 1 of x comma t. It will be equal to e to the power x minus t into x minus t the whole power n divided by n factorial. So what is the summation of this series? Take out the terms which are independent of n. So you can take out e to the power x minus t outside. So we will solve it. E to the power x minus t is independent of n. So you will have summation n is equal to 0 to infinity 2 to the power n. So x minus t the whole into 2 the whole power n divided by n factorial. So in this type only the equation is. And what is the formula for this one? 2 to the 2 of x minus t the whole power n divided by n factorial, and summation n is equal to 0. You will find 1 divided by 0 factorial, which is equal to 1. If you put n is equal to 1, you will find 2 times of x minus t divided by 1 factorial, and when you put 2, you will find 2 times of x minus t the whole square divided by 2 factorial. This is the formula for exponential series. So exponential series formula, e to the power x minus t, this is e to the power 2 times of x minus t. This is the formula. Since e power x is equal to 1 plus x by 1 factorial plus x squared by 2 factorial plus so on. So this is the solution. So your R resolvent kernel will be equal to e to the power x minus t into 2 times of e to the power 2 times of x minus t. So when you add the powers, resolvent kernel R of x comma t comma 2 will be equal to e to the power 3 times of x minus t. Now here we have to replace the variables. We have replaced y. We have to replace y by phi, and we have to replace t by zeta. So r of x comma zeta comma 2 will be equal to e to the power 3 times of x minus zeta. So this is the solution. E to the power 3 times of x minus zeta. So option 3 is the correct answer. Problem in part C. An integral equation involving a parameter lambda. Phi of x is equal to cos. This question it has a mistake. It is cos 2x plus lambda times of integral 0 to pi cos of x plus zeta into d zeta. Again, by using the convenient variable, y of x is equal to cos 2x plus lambda times of integral 0 to pi cos of x plus t into dt. Now zeta has been replaced by t and phi has been replaced by y. Now here your f of x is given by, this is a Fredholm integral equation and it is not Volterra type because you have the limit. Limit is finite. So you have f of x is equal to cos 2x and k of x comma t, it's a quite big problem. K of x comma t is cos of x plus t. The formula for cos of a plus b is cos a cos b minus sin a sin b. So cos of x plus t will be equal to cos x cos t minus sin x sin t. Here alpha 1 will be equal to cos x and then beta 1 will be equal to cos t. Alpha 2 will be minus sin x and beta 2 will be equal to sin t plus sin t. Okay, so in order to find the solution, we need to find whether it is coming on a unique solution or no solution or infinitely many solution. So we will find the matrix Ax is equal to B, and as like linear algebra, we will solve the problem. A matrix is a 1 minus lambda A11 minus lambda A12 minus lambda A21 and then 1 minus lambda A22. Since you have alpha 1, alpha 2, beta 1, beta 2, you'll stop till 2 by 2 matrix. And then your X matrix will be C1, C2. And then you will find the B matrix is equal to V1, V2. From this matrix type, we will evaluate the solution type. Now, Aij will be equal to integral, whatever be the limit, integral A to B, beta I of x into alpha j of x into dx. And Vj will be equal to integral a to b your f of x, which is not equal to 0, and then beta j of x into dx. So we will find one by one. Now here we need this alpha 1, alpha 2, beta 1, beta 2. A11 is equal to integral. What is the limit of the integral? Integral 0 to pi. So integral 0 to pi, beta 1 is cos x into alpha 1 is cos x into dx. Okay, what is the formula we know? Integral 0 to pi cos mx into cos nx dx, which is equal to 0 when m is equal to n, and it is when is m not equal to n, and pi by 2 when m is equal to n. Now here m and n are equal, therefore this is equal to 0. So we get it is equal to pi by 2, and A12 will be equal to integral 0 to pi beta 1 of x into alpha 2 of x. Beta 1 of x is cos x, and then alpha 2 of x is minus sin x. So I'll write minus sin x into dx, which is equal to, we know the formula that integral 0 to pi sin mx cos nx is equal to 0 if m is equal to n. If m is equal to n, in that case, we will find it as 0. Okay. Next one, A21 is equal to integral 0 to pi. We need to write beta 2 and alpha 1. Beta 2 is sin x, alpha 1 is cos x. So again, sin x into cos x, this will be 0 and this is also 0. And A22 will be equal to beta 2 and alpha 2. Sin x minus sin x. So you will have the integral 0 to pi sin x into dx. So that is equal to, we know the formula, integral 0 to pi sin mx into sin nx dx is equal to 0 if m not equal to n, pi by 2 if m is equal to n. So we will find this as equal to pi by 2. And here, since we have a negative, we will find a negative here. Okay, so the matrix A would be 1 minus lambda A11, right? So 1 minus lambda pi by 2, 0, 0, 1 plus lambda pi by 2. And then your V1 and V2. V1 is equal to integral 0 to pi cos 2x into beta j, that is beta 1. Beta 1 is cos x. So cos x dx. So we know that cos mx cos nx is equal to 0 when m is not equal to n. Here m is equal to 2, n is equal to 1, so it is equal to 0. What about v2, which is equal to integral 0 to pi cos 2x does not changes because it is the f of x, and we need to find beta 2. What is beta 2? Which is equal to sin x. So this is equal to sin x into dx, which is equal to integral 0 to pi sin x into cos 2x into dx. Now what is the formula for integral 0 to pi sin mx into cos nx dx? This is equal to sin mx into cos nx dx. So sin should have m and cos should have n. If you replace, the formula will change. Okay, wow. So minus 1 by 2 of cos of m plus n of x divided by m plus n plus cos of m minus n of x divided by m minus n. This is for whatever be the limit integral a to b. So we find this. So v2 is equal to, here m is equal to 1 and n is equal to 2. So minus 1 by 2 cos of 1 plus 2 x divided by 1 plus 2 plus cos of 1 minus 2 x divided by 1 minus 2. Your lower limit is 0, upper limit is pi, which is equal to minus 1 by 2 cos 3x divided by 3 plus cos x, because cos of minus x is cos x, divided by minus 1 integral 0 to pi, which is equal to minus 1 by 2 cos 3x by 3 minus cos x, cos 3x by 3 minus cos x 0 to pi. When you apply the limit for the result, minus 1 by 2 cos 3 pi by 3 minus cos pi minus of cos 0 by 3 minus cos 0. So that is equal to minus 1 by 2 cos 3 pi, which is equal to minus 1 by 3 minus 1. Cos pi is minus 1, so minus into minus you will find plus 1, and then minus 1 by 3. This is cos 0 is 1, so minus 1. So that is equal to minus 1 by 2 outside, minus 1 by 3 plus 1 minus 1 by 3 plus 1. So that is equal to minus 1 by 2 minus 2 by 3 plus 2, which is equal to minus 1 by 2 minus 2 plus 6 by 3, which is equal to minus 1 by 2 4 by 3, which is equal to minus 2 by 3. So your V2 is minus 2 by 3. A matrix, we know the matrix. So A matrix is 1 minus lambda pi by 2, 0, 0, 1 plus lambda pi by 2, and we got C1, C2, which is equal to your V1 is 0 and V2 is minus 2 by 3. Now we will see what are all given in the options. So in the first option, it is given that a unique solution if lambda is equal to 1 and an infinite number of solution when lambda is equal to 2 by pi. Now verify at lambda is equal to 1. When lambda is equal to 1, we get A is equal to 1 minus pi by 2, 0, 0, 1 plus pi by 2. So find the determinant of A, which is equal to 1 minus pi by 2 into 1 plus pi by 2, which is not equal to 0, therefore unique solution. Unique solution when lambda is equal to 1. When lambda is equal to 1, we get unique solution. So first half of the option A is true. First half is true. Unique solution when lambda is equal to 1 is true. And an infinite number of solution if lambda is equal to 2 by pi. Let us verify. When lambda is equal to 2 by pi, what will happen? Here lambda is equal to 2 by pi. A is equal to 1 minus 2 by pi into pi by 2, 0, 0, 1 plus 2 by pi into pi by 2. So this will give you, this part will be 0, 0, 0, 2, and yes, so determinant of A is equal to 0. So when you determine the determinant is equal to 0, it can have unique solution or it can have infinitely many solutions. So in the next step is we need to verify with the matrix B. So this is your matrix B and this is your X. So we need to verify with rank of A by B. Rank of A is 1 here, right? So find the A by B augmented matrix. So here it is 0, 0, 0, 2 and B matrix is 0 minus 2 by 3. So here rank of A by B is also equal to 1. Both the ranks are equal, therefore infinitely many solutions. Good. So we get infinitely many solutions. So the second half is also true. So option 1 is fully true. And what about your second option? A unique solution when lambda is equal to minus 1. We will determine when lambda is equal to minus 1. Lambda is equal to minus 1. So we have A is equal to 1 minus lambda into pi by 2. So we get 1 minus lambda into pi by 2. So we get 1 plus pi by 2. Then 0 here, 0, 1 minus pi by 2 and here this is having determinant not equal to 0, therefore unique solution. So the first half of this option is true. First half is true. What about the second half? An infinite number of solution when lambda is equal to minus 2 by pi. When lambda is equal to minus 2 by pi. Lambda is equal to minus 2 by pi. A is equal to 1 minus, what is your lambda? Minus 2 by pi into pi by 2. 0, 0, 1 plus minus 2 by pi into pi by 2. So this is equal to, here you will find 2, 0, 0, 0. So determinant of A is equal to 0. Rank of A, find rank, which is equal to 1 here. Find rank of A by B. Rank of A by B. We need to find this one. So for that, write the augmented matrix. We will have 2, 0, 0, 0 and then 0 minus 2 by 3. Here, the rank of A by B is not equal to 1. It is actually equal to 2. Both are not equal, which is not equal to rank of A. Therefore, no solution. No solution when lambda is equal to minus 2 by pi. No solution when lambda is equal to minus 2 by pi. So what about the option B? Option B, it is given infinite number of solution and lambda is equal to minus 2 by pi. So option B is wrong. And a unique solution if lambda is not equal to 2 by pi. Let me take lambda is equal to minus 2 by pi. In that case, we get no solution. No solution in this case. Okay, so this option is false. And no solution if lambda is equal to plus or minus 2 by pi. In plus 2 by pi, we get infinitely many solution. So this option is also wrong. So only one option is true.